All right, hello and welcome to our first live office hours of the semester. So just by way of quick introduction, so these are my open office hours. I am this semester I'm teaching 7 different classes at 3 different colleges, and anyways, I thought that rather than offer limited office hours to each college where students may or may not be able to attend, that I would just open all of them up to everybody, and hopefully it'll serve all of your divergent schedules as best as possible. So this is our first. We'll be here every Monday from 1 to 1 to 2. In addition to my other office hour times, which I posted in each canvas. Just so you know, I do have to leave on the hour because I have another class to get to. Not on YouTube. I have a few Zoom classes this semester, so I've got to bounce over to that. But I'm here and I'm ready to answer questions. If you have any, go ahead and hit me up. Hit me up with cues in the chat. If there are no live questions, then I will go to some. I know I had at least one submitted over email. Let's see, right over here. So we do have one email question. If there are no live questions, but if you have questions live, go ahead and lob them out at me. But if not, I'll go ahead and answer this one that I have waiting in my inbox. So this first question coming in is, a Chem 400 question. Oops, I don't know why. There we go. Made that disappear. Okay, so this is a question from Lecture 2, Chapter 2. It's a boss level question. So in my lecture stream, I ended with a question, but no students asked about it. Okay. So here, I'm going to take a minute and look this one up. Let's see. Hey, babe. Okay, sorry about that. I had, or have, oh, let's see. Ah. Oops. All right, so This is Lecture 2, Chapter 2. All right, so I am all right, so what I'm going to do real quick is I'm going to, I'm going to write out what this boss level problem is. That way, if you're watching on this stream, you don't have to find, it in the previous stream. And then we'll break it down over here. Because again, this is from chapter 2, right at the end of chapter 2. I left off with this problem, so try this on your own. But nobody asked about it, so there's no actual answer in that stream. So here is our example. So here's the question. How many molecules of water are in 1.00 milliliters, or sorry, in a 1.00 milliliter sample question. And we're also given that the density of water is 1.008 grams per milliliter. A vignette. It totally is. This is totally the boss level problem from the end of chapter 2, which lands right in the middle of the second lecture. All right. So anytime you're trying to solve a problem, the most important thing to do is identify what you're trying to find. If you don't know your target, if you don't know your goal, you won't be able to find your way there, right? So that is the number one thing you want to identify is what are you trying to find? And the answer is here, right in here, we're trying to find the molecules of H2O, right? Now, once you know what you're trying to find, the next thing you want to look at is what are you given in this problem? All right, what are you given? Now, so this is where you want to assess, analyze your situation for given information. One thing that we know is we are given a volume, right? We have a 1.00 milliliter sample of water. All right. We are given a second piece of information. We are given the density of water. We're told that the density of water is equal to 1.008 grams per milliliter. Now, this is where something very important, a very clutch test-taking strategy comes into play for the first time in our course. So anytime you're given a quantity like density that has a corresponding algebraic expression, you want to write that information down as part of under your given information. All right, density is a quantity that has a corresponding algebraic expression, and that expression is this. Density is equal to the mass of a sample divided by the volume of a sample. All right, density is equal to mass over volume. And when you look at what we're given here, we are given both the density, right? We have the density of water, and we have the volume of water. So what does this equation buy us? What this equation buys us is the ability to solve for mass. All right, we can solve for the mass of water. Now, is that what we're trying to find? The answer is not exactly. All right, we've been asked to find molecules of water, and this equation allows us to find mass. But, and if you haven't seen lecture 2, a little bit of a spoiler alert, but this lecture is all about it's all about, well, not all about, but an important part of this lecture is converting between the mass of a substance and the moles of a substance, right? We know that if you have a mass that you can convert to moles using AMU, right? Using atomic mass units. And if you have moles, you can convert from moles of a substance to the particles using Avogadro's number, right? Using 6.022 times 10 to the 23rd. So this equation allows us to solve for the mass, and we can use both the atomic number and Avogadro's number to convert from mass, the mass of our sample, to the number of particles, and that is exactly what molecules is here, is the number of particles. So we've got 2 steps ahead of us to solve this. First, we need to use the density and the volume of our sample to find the mass of our sample. Then once we have mass, we can use the atomic mass units for water and Avogadro's number to convert from grams of water to molecules of water. Right now I'm going to zero this out, and we're going to open a new slide. And we will get started. So step number 1, we're going to use our equation for density. Density is equal to the mass of a sample divided by its volume. Now we want to isolate mass on one side of this equation, so we're going to multiply both sides by volume. Volume cancels on the right side of our equation, so we get a new equation, or a rearranged equation, where we have mass is equal to density times volume. Now our density of water is 1.008 grams per milliliter, and our volume is 1.00 milliliters. Now, our volume unit is in the denominator and the numerator, so it cancels. We're just left with grams, which is good because we're solving for a mass. So the mass of our sample is equal to 1.008 times 1, which is 1.008. Now, we can't quite get off that easy because we have to consider sig figs, all right? You always have to consider sig figs. Now here, we're doing a multiplication where we're multiplying 1.00, which has 3 sig figs, times our density, which has 4 significant figures. And when you multiply two numbers, your answer must have the same number of significant digits as the one you multiplied with the least. So our answer must have 3 significant digits. I'm not going to round right now because you should wait to round to the end of the problem. But I am going to put these lines underneath my mass to remind myself that this number, this value, only has 3 significant digits. All right, now that we know the mass of water, we're going to use this to find its how many molecules are in the sample. So we have 1.008 grams of H2O. And again, 3 significant digits in this number. Now we need to do a couple of unit conversions. First, we need to convert from grams of water into moles. And then we need to convert from moles of water into molecules. All right, those are the 2 steps for a unit conversion. Now, first off, moles to grams. Now, we learned in this lecture, and this is what makes this problem next level, because we didn't explicitly talk about molecules, at least at this moment in time in the lecture that I'm referencing. But we learned that if you looked at the periodic table, it tells you the atomic mass, which are the number of grams, the mass that 1 mole of a substance weighs. So, for example, if you look up hydrogen, hydrogen has an atomic mass of 1.008 grams per mole. All right. You can look up oxygen. Oxygen has an atomic mass of 16.00 grams per mole. All right. But you won't find a molecule of water. It's the periodic table of elements, right? There are only elements present. To find the unit conversion to convert from grams of water to moles of water, what you have to do is you have to add up the individual atomic masses of every element in the compound, and that'll give you your unit conversion. Now, in this problem, we have 2 hydrogen atoms, so we need to multiply this 1.008 by 2, and then we have 1 oxygen, so adding these together will give us our atomic mass. The atomic, not atomic, because it's not an atom, molecular mass. The molecular mass of water is 18.016 grams per mole. Now, sig figs wise, we just did an addition, and the least precise number of the numbers I added was 16.00. That means the last significant digit in this number has to be in the second decimal place. And so we have 4 sig figs in our answer. Again, I'm waiting to round to the end. But I'm going to put 4 lines underneath this number to remind myself that I'm dealing with 4 sig figs. All right, now grams of water. Oh, wait, hang on. I just messed up. Let's try that one more time. There we go. Four sig figs. And now grams of H2O cancel grams of H2O. Next, we need a unit conversion to go from moles of water to molecules, and that is where Avogadro's number comes in. 1 mole of anything, so 1 mole of atoms, ions, molecules, what have you, is 6.022 times 10 to the 23rd. And so moles of water cancel moles of water. We're left with molecules. Now, again, this number, Avogadro's number, is not exact, so it has 4 sig figs as well. However, all of our units have canceled. We're ready to crunch our numbers and calculate our answer. So I'm pulling up the worst phone, not the worst phone, the worst calculator ever, right? It's the basic one on my phone. But let's crunch these numbers. 1.008 divided by 18.016 times 6.022 times 10 to the 23rd. And now my calculator is giving me an answer. And the answer is 3.3693325 times 10 to the 22nd molecules of water. Now, so that's the correct value. Something I mentioned in lecture, and this is something that you'll want to keep in mind as you move throughout this semester, is the correct answer has 3 components. There's the correct value, the correct units, and the correct sig figs, all right? Correct units, already here, it's molecules of water. Correct value, we have that, but we need to make sure our answer has the right number of significant digits. And if you look at this problem, we have 4 sig figs in Avogadro's number. We have 4 sig figs in our molecular weight, but we only have 3 sig figs in our mass. And so since we are doing a multiplication, our answer must have 3 sig figs. So we're going to count off 1, 2, 3. 9 rounds up. And so then our final answer will be 3.37 times 10 to the 22nd molecules of water. All right, and that is the answer to this boss level problem. So yeah, that's how that goes. All right. Wassel. Great question. Wassel, all lectures for Chem 400 are already posted and available for on this channel under the channel playlist Chem 400 lecture. I think it might have some added things to it, but it's the Chem 400 one. You can watch the entire semester's worth of lectures as rapidly as you want to. But I recommend, so I put in the syllabus a viewing schedule, and I recommend hitting that up so that you don't fall behind, because the one thing that won't change are the exam dates. So you want to make sure that you're staying on pace with lecture so that you're ready to take the tests as they become available. Avinya, you bring up a good point. So there are slight variations in atomic masses depending upon the periodic table that you use. But the atomic mass of water is not 18.08. I feel like you've got something wrong there. Anytime, dude. Because the thing is, when you look at water's atomic mass, or not atomic, sorry, molecular mass. Or molecular weight. Oxygen's atomic mass is always around 16.00 AMU. Like sometimes you'll see 15.998 AMU used for oxygen. Hydrogen's is always around 1.01 to 1.008 AMU. Sometimes you'll see 1.0079. Okay, that helps me out a ton. Awesome. Thanks for writing that out. Yeah, Avinya, I think looking, yeah, totally. I think it was a calculator error because your masses are spot on. So I think that was the deal there. Totally. Alrighty. So at this moment in time, so that was the only question waiting for me in my inbox, which I'm gonna check, refresh them to see if I missed anything. But in the meantime, if you guys have any new questions, hit me with them. I'm going to start checking emails, seeing um, if I missed anything. But if I haven't, then I'm waiting on. Oops. Excuse me. Waiting on you all. All right, none there. None there. Hey there. Let's see, when I say algebra for the prereq, do I mean everything listed in the syllabus, like polynomials and such? Yes. Yeah. All the stuff that's listed in the syllabus, I believe shows up in some capacity on the prereq exam. Totally. So I would definitely look, brush up on stuff if you're feeling a little shaky. But yeah. Oh. Dude, Chem 401 is a significant step up. Um, but honestly, like, it is a step up in difficulty, but it comes with an increase in just the cool chemistry you get to learn. So what I miss about 401 is the kinetics stuff. So you'll start looking at reaction rates, how fast they go, what causes increases, decreases, all that good stuff. And that will lead into a discussion of chemical equilibrium, where you start exploring reactions that are reversible. Turns out you'll learn that technically all reactions are reversible. Um, in practice, many of them aren't. They act irreversibly. But there's some of the coolest stuff in Gen Chem is in the second semester. So it's a lot harder. There's a lot more math. There's a lot. There's a lot, but there's also some really cool stuff that go hand in hand with it. So it's a trade-off there. One that I'm happy to make, but again, it's also different when you're sitting in the instructor on the instructor side of the desk. So I get the nerves of being in that class as well. As long as you hit it hard though and stay on top of it, you'll be okay. The biggest danger for Chem 401 is falling behind. Okay. Avinia, that is an excellent question. The reason why organic chemistry has a reputation for being harder than general chemistry is that with general chemistry, it's more or less a survey course, which means that you deal with this topic, and then you move to this topic, and then you move to this topic, and you kind of go down the line. Now, that's not to say that you can forget each topic as you move through, right? Stoichiometry never really goes away. Sig figs are always kind of there. But it's not like you need everything you learn along the way for the next chunk of the course. Organic chemistry is one of the only truly cumulative classes out there, in that everything's built on everything else. And you need the past to be able to understand the future. So when you sit down to take your final of second semester general chemistry, you will be tested on stuff that you talked about week one. Sorry, I said general, I meant organic. When you take the final for second semester organic chemistry, you will be tested on stuff that you learned week one of first semester OChem. So that's one of the reasons why it's challenging. It's because you're never allowed to forget anything. Everything builds on itself. Another reason why it's challenging is because of the integrated nature of the course. If you fall behind or you don't understand the material that's in your rear view that you talked about already, you're not going to be able to grasp the new stuff coming on. So with Gen Chem, at least there's, like this semester, a lot of students struggle with redox reactions. You do redox, you struggle with it, maybe you don't do that well, but you move on and you don't really see them again until the final, right? There's going to be some redox stuff on the final. But it's not like you need the redox stuff to do the thermodynamics chapter or the electronic structure chapter. You can kind of leave it behind until you have to relearn it for the final. With organic chemistry, you can't move ahead. You won't be able to grasp the next chapter if you don't understand the chapter you're in. And often what I see is students fall behind and then they're never able to recover. And so that's one of the reasons why organic chemistry has a hard rap, or a bad rap, or I guess a reputation for being difficult. The other reason why organic chemistry is particularly challenging is there's a lot of memorization involved. There can be, depending upon how it's taught, but no matter who's teaching it, there's going to be some. But it's not a class you can memorize your way through. It's not enough just to know the facts. You have to know all these facts to then apply them and problem solve in a variety of situations. And so it's challenging because it's thoroughly integrated. It's challenging because there is a large quantity of information that you must know. But then you need to take that quantity of information and be able to apply it to diagnose situations, to problem solve. And so that's why OChem has the reputation of being so much harder than Gen Chem. And the weird thing is, there's almost no math involved. Normally, students think like hard equals math. There's almost no math in OChem, and so I think that's also part of why it's a challenge, because you're dealing with a situation that's completely different than any other class you've gone through. But so that's the reason why it's kind of the STEM boogeyman, or at least the pre-med boogeyman. But let me tell you why I love it. And this is a commercial for a class that you may or may not have to take. But here is organic chemistry. Ugh, or maybe that's organic chemistry. In one sentence. All right. Organic chemistry is one simple premise. If you understand the structure all right, if you can understand the structure of a molecule, you can predict its reactivity. If you can understand the structure of the molecule, you can predict its reactivity. That is the premise of all organic chemistry. And so what organic chemistry is it's a in-depth, deliberate exploration of structure, and then applying that knowledge to reactivity and developing the connection between the shape of a molecule and how it behaves. And honestly, that's why I love the class, because I feel like Gen Chem teaches you things you need to know about chemistry, but OChem teaches you actual chemistry for the first time in your lives. And so that's the beating heart of it, and that's why I love the class. And it's challenging, but it's fascinating. So anyways, that was probably a longer answer than you were looking for, but I feel like it was fairly thorough. In the spirit of full disclosure, I'm an organic chemist, so that's also kind of my beating academic heart right there coming up. But that's why I love that class. And who knows, maybe you'll like it too. Dude, that's awesome. I was pre-med too. I was actually back when I started college. I started out pre-med, and I took organic chemistry because I had to, right? Because it's on the MCAT, and I was terrified, and so I studied for that class harder than I'd ever studied for anything else in my life. I'd never worked so hard for a thing, and I realized two things: that if you can stay on top of it or a little bit ahead, um, it wasn't as bad as everyone told me it was going to be. But then the second thing that I learned was that I actually loved it. That it wasn't as hard and I loved it. And that was kind of the pivotal moment for me where I went from being pre-med, like I'm going to go to med school, to I just want to be a chemist. I just want to do chemistry. And that's what landed me in this chair streaming right now. So yeah, and not that I'm saying like, oh, so I hope that you also abandon your pre-med dreams. I think med school's awesome, and being a doctor's an excellent career. Probably better than being a community college professor, but you know, it was the way things ended up, and I wouldn't be doing anything else. I thoroughly, thoroughly enjoy my job, especially when I get to teach OChem, which I actually do. Not at FLC this semester. I'm teaching a couple of OChem labs over at Sac State. Whoa. Those are words that I live by. There we go. Totally. So we've got about around. Oops. Oh, okay. Avi. Okay. Awesome. Dude, I will do my best to remember. My memory's a little bit like a sieve, but I'm going to, as always, do my best to learn everybody's names, and eventually it kicks in. Might be a little deeper into the semester than most professors. Sometimes speaking is hard, but I eventually get there. We have about 10 minutes left in this office hours before I got to bounce. So if anybody has new questions, I can totally take them. But I will have to go at the top of the hour. Hey, Alexis. Fire away. Okay, here. Give me one second. I will pull that up. All right. Let's see. Problem lecture 2, chapter 2. And then you said this was 3452. Okay, let's see. 3452, lecture 2, chapter. I'm getting almost the same decimal, but like 3 digits off. Okay. Oh, okay. Yes. All right. Yes, totally. Okay, so Alexis. So we have, so this is the situation we have here. We've got 13.0 times 10 to the 8th atoms times, let's see, 1 mole carbon, and then it's over 6.022 times 10 to the 23rd atoms of carbon. All right, so here's the deal. When you punch this into a calculator, so, we set this up so that atoms cancel. We all know. You enter it in. When you're entering this into your calculator, there is a trick. So you got to get good, depending upon the calculator you're using, but this is pretty applicable to all of them. you have to get good at entering, or sorry, at using parentheses. When you're dividing, so we're dividing by 6.022 times 10 to the 23rd. You have to put parentheses around the entire Avogadro's number, because if you don't, without them, without the parentheses, the calculator reads it as 13 times 10. If you don't put the parentheses in, 13 times, or sorry, that's 13.0. Let me just be accurate here. Without the parentheses, it reads it as 13.0 times 10 to the 8th divided by 6.022 times 10 to the 23rd. Your calculator assumes that this is what you mean. Right? Your calculator thinks that you want to do 13.0 times 10 to the 8th divided by 6.22, enter, and then multiply the whole thing by 10 to the 23rd. And that's why you're getting that 10 to the 31, because where that 31 comes from is if the 10 to the 23rd is not in the denominator, then it's adding that 10 to the 8th and 10 to the 23rd. That's why you're getting 10 to the 31. So whenever you are dividing something and you're using a calculator, this is the big take home right here. Make sure you throw parentheses around everything in your denominator and then hit enter. That'll ensure that your calculator handles your exponents of 10 properly. Whoa. Let's see. Alexis, I totally will. Good. I'm really glad that we could clear that up. I'm going to make a note to myself to upload a periodic table so that I don't forget. All right. Let's see. All right. Okay, cool. I will get that periodic table up onto Canvas. And this brings our first officers to a final close. Thank you for everybody who came out. We had some good questions, good discussion, even some philosophical stuff about OChem, which is always a blast. I will catch you next time. Just as a reminder, we have office hours tomorrow from 8 a.m. to 9 a.m. And again, I've got to run to a class after that. So it'll be a strict hour, and I got to bounce to my class now. So thanks, everybody. And I will catch you next time, possibly tomorrow early in the morning.